Uh, okay, hello. So currently I'm going to talk about system design. I am reading a book about it. So I'm going to talk about the initial around 8, 9 pages which I've read for it. System design is something which talks more about how we create backends and not just backends in general, a whole development system and the interactions of the services with each other. How do we set up them? That pretty much comes under system design, and it's kind of a important thing to just generally know. At least the things which I'm talking in this video are generally good to know. In normal world and even the projects which I've made in my college, I just had one front end or the user slash front end in them, and I just had it directly talking to the backend server. Right. What is this? This thing just has my code. It was my fast API code over here, which it was directly talking to. So they were communicating with each other back and forth, and that is pretty much it. How I was making my system design back in the day. Now, uh, this is okay, but you know, not so great of a thing. So the first thing which will come in over here will be our DNS because in real world we don't put our app on our IP address, right? We usually put our app, let's say, on google.com. So that's a different alias name for the actual location for the website. So this alias name or a domain name is something we buy. And what really happens is that we have a DNS server. We don't own DNS, don't worry about them. It's all something maintained by the people online, the ISPs, the big people who actually maintain the internet. They have a server which basically keeps a record of they have a key value pair going on. Okay. So let's say www.google.com is the key and the value for this might be some 9192 dot something something 00. The IP address which has been associated for it. So they hold a key value pair system in there at in the DNS server. DNS server is nothing more than this domain name server. Okay. Our front end or usually our browser talks to this DNS. Okay, it gives it this google.com. Okay, and now the DNS will reply back with the actual IP address of the thing we're trying to access. Now we will go to this IP address, which is over here, which where we find our backend server directly. Okay, now you understood front end passing our actual URL, which goes to the domain name server, which is not maintained by us, uh, with nothing to do with us. When we actually buy this domain, we usually provide them this actual location for that. So they map this key to this value, and then anybody who accesses this will be redirected to this IP address. Okay, and now we go to this IP address, and there are backend exists. Okay, server. Now, the problem with this thing is we are directly letting our front end via the IP address come to our server. We are not really managing the DNS, so it's just kind of directly coming to our server, which um, is fine, but it's usually recommended to keep a middleman in there, which turns out to be a load balancer. We'll get back to the name of it, but at most, the first thing which it does, okay, we'll put the load balancer over here. The front end is gonna call this IP address. Okay. Now this is a public IP. Okay, which is given to our DNS. This is public, which goes to a load balancer, which is also kind of like a server. Okay, which is kind of like a computer with a coded and everything. in it, or sometimes we do it like stay, without any actual server. So serverless kind of thing sometimes happens, but that's something we can figure out later when that we really do. So we go to the public IP, which is this. Now the load balancer will actually verify if it's a proper thing or not, if it's not something malicious, and then pass it to the server. How does it pass it through? It provides it with a private IP. It redirects the traffic with a private IP, which might be something else, which might be something totally different. Okay. So normal setup, most commonly, at least we bare minimum should have this kind of setup going on. Front end, obviously, we have to pass it to a DNS. That's kind of a mandatory thing, which provides you a public IP. Now, that public IP will redirect to a load balancer server. The load balancer will check if it's a real person or not a malicious thing happening, and then pass it through to the private IP. Give it a private IP to the traffic, and that private IP at that private IP, a server will exist. Okay, pretty simple, nothing complicated. Now, what if the load on a backend increases, right? A lot of users are trying to access things at once and it is getting difficult to manage. So we can do two things to our server. Okay, this is a server. I'll take it over here. Right, we have two options to handle this increased traffic. Okay, the first thing we can do is horizontally scale it. What does horizontal scaling means? Horizontal scaling means we are just gonna increase horizontal scaling. This means we are gonna increase the CPU slash the memory or etc, something like that, right? We are increasing the specs of the server. When I increase the specifications, specs, okay, of the server. This is horizontal scaling, which on a small level works, but as soon as we go on a bigger level, it's not really a good thing and can just burn a lot of money and it's not so feasible honestly. So it's just better to go with vertical scaling most of the time. Vertical scaling means we are gonna increase the number of servers. Okay, so let's try to vertically scale the system. We are just gonna create one more server. So there will be server S1. Let's make it smaller. Okay, then S2. So we basically did what? We did vertical scaling. Now, since we already have a load balancer, and the job of load balancer is to verify and to provide a private IP and also to pass out the load according to the freeness. Okay, so it will now have two private IPs which it can redirect traffic to. This might be a different IP altogether. This will be a different IP, not might be, it is gonna be a different IP where our two servers will exist. So we basically did what? We simply just vertically scaled our system over here. Okay, this is vertical scaling. I'll keep both of this on the side. That's just notes, not really mandatory to keep it over here. Okay, so this is vertical scaling. We increase the server. We can do is that we can add more. Okay, we can add even more servers over here, which will have a different IP provided to it. Now, the load balancer will manage and provide it. We will probably code an algo in there. There are multiple algos in them. One of the simpler algos are just to do a one, two, three system. Okay. The first one goes over here, the second request which came over here, third over here, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12. Like this, segregating the number of traffic which is being given to you, which is quite simple, but then there are a lot more kind of algorithms which exist, it's just kind of something we can figure out later, not in this video, okay? Okay, two different IPs, three different servers which are vertically scaled. Now, the database is in the server itself. The problem which we're going to face is that three of them are going to have three different databases now. How would they know the changes everywhere happening? They need to communicate. Okay, let's just do one thing. Let's just create another server. Okay, let's just create another server and we'll just keep our database over there. It will have nothing else than our database in there. The only task or the job of okay, that's weird. The only task of the server is to just be our PostgreSDB or our MongoDB or whatever. The only thing which is going to run on that server is our database, DB. Okay. So to deal, this is quite normally the setup we do when we are doing vertical scaling. User goes to DNS, gets the public IP given to a load balancer. According to the availability or the algo we have coded, it will pass it to a private IP, either of them. It will go to one of the private IPs, and now private IP, all of these servers have the access to DB. There is one singular DB in this thing. Pretty simple, pretty flexible, pretty good. Right? We have done vertical scaling. It's good and all. But now, let's say the operations on DB is getting heavy. We are doing a lot of accessing, writing, and a lot of things on the DB. Now the DB is getting tired. We have to scale our database now. If the server load is increased, we can just create even more servers. That's fine. But we can't just create another more DB. That's going to be really difficult because then problems will fail. Okay, so now how do we deal with this DB part, database? We'll come on the side and we'll talk about the database part. Okay, what we usually do is we create a master DB and a slave DB. Okay, master slave system. We had uh, you might have learned about, you might have not, but yeah. So the master DB, the only job of the master DB is to write data in it. Okay, whenever you want to write data into it, or to be correct, if you do a post request, if you remember post request, we are adding or creating something. If you do a put, we are updating something. Or okay, I'll just do it like this: create, update, and delete. Okay, if you're doing three of these things, we are gonna come to the master DB. Okay, if we are just gonna get something or read something, we are gonna come to the slave DB, right? Now, we'll also create an algo or a system by which we will always keep replicating the data which is over here to here. We'll perform replication, right? What does this replication means? After a certain interval of time, whatever the changes, or even not even interval, like pretty much instantaneously, whatever changes are made over here will be updated over here. I mean, that sounds really weird, but why we are doing this? Because in modern apps, just think about it. Most of the operations are read. Okay, other operations are rare to happen. Okay, even let's say in Instagram you watch, it's really rare for you to create posts and like create stories and stuff. You a lot of time, or most of the calls you make via Insta or to the backend is the read call. Okay. When you're opening the home page, the feed is being read, the story is being read, the people being read, your number of followers, everything. So many read operations happen. But your create, update, or delete operations are really minimal. Okay. So the goal of bifurcating both of them is that the read operations are so common that we just create a different DB which just deals with the read operations. And the create, read, update are done by a master. Okay. Usually there is one singular masters. We don't really replicate slaves. We do not vertically scale them as well. And master is usually horizontally scaled. Horizontal scaling is when we are increasing the storage capacity of master. But on slave, we usually prefer vertical scaling slaves. Okay, so this is a slave two. This is a slave one. We are doing read on this. So let me just connect with it. Thank you. Snap, snap. Okay. So replication, it keeps happening, the replication keeps happening, but the main database is just the master. Then we have slave, and then we usually vertically scale the slaves. Okay, so we'll try to put this into this system now. Okay, we'll delete this DB. I'll delete one server as well just to make it clean. We'll put it a bit away, away like this. Delete this. Okay, slide it away. And also one more benefit of having a slave is that data redundancy happens. So let's say for some reason by mistakenly a master collapses. We can do what is we can create the slave as a new master. We can make this slave a new master. We can create a new slave over here, and then we can make this as a master, right? So that we have extra data always. So like for some reason, if this DB crashes, we always can use the slave as our new master because it has the same data as that. Okay, now I'll put it over here. This server can either do two of the things, right? It can either try to update or read. Sorry, it can do create, or I'll say create, okay, update and delete. Okay, CUD, and this thing I can also do CUD, which is create, update, and delete, which will both just directly do it to the master without having any problem. Okay, but when they want to read something from a DB, they will come over here. Now we'll create another kind of like a load balancer system going on over here. Okay, let me see how they go. They didn't recommend a load balancer, but so we will actually need like another load balancer or a small algo. Not like a proper load balancer, it's just like traffic manager kind of a thing. Right, that's something we can code it out when we do. Which will sit over here. The only task for this part is to just direct to the whichever is more free comparatively DB, okay? And then this thing also calls over here, okay? like this. So this is the system which usually exists in our normal system designs on average on even, you know, your big enterprises use this. So I'll recap. The front end passes the URL, which goes to the DNS server, which is not by us, nobody, gives us a public IP. We now use that public IP to go and connect with the load balancer or the proxy in between, but okay, let's just call it a load balancer. I'm not going to complicate that thing. Which will give us a private IP. Okay, that private IP will be either how many server that might be. It will redirect to one specific server. The job of the server now is just to do business logic and do the brain part of it. Now, if this server wanna update something in the DB, create, update, or delete something in a DB, it will go to the master DB directly. But if it wanna read something, it will go to a traffic manager, kind of like a DB traffic manager is a better term. A DB traffic manager, which will pass it to a slave DB. Okay. Now this master and slave continuously, whenever there is some operation happening over here, it will replicate the same changes on the slaves. Okay. And I think that's pretty much it. If you have any doubt, you can drop in the comments or text me. Okay. See ya.